Hi everyone, I'm Karthik Lalithraj, Principal Solution Architect with Kinetica. Today I'm going to show you the power of an in-memory based database that's backed by GPUs. So today I'll show you a little bit of the architecture and also a brief demo of the product. Okay, let's get started. The Kinetica Architecture. The Kinetica Architecture allows you to store tens of terabytes of data and allows you to linearly scale on demand. This architecture shows you four different Kinetica nodes that are interacting with each other. Ingest of data could be through a head node that's on each of these different nodes. The architecture also allows disk-based persistence, which could be SSDs or flash drives, and data replication for high availability purposes. We also allow you to on-demand scale up and scale out. The Kinetica architecture allows a variety of APIs to connect to the database itself. We offer REST-based API, which most of our customers use. We also support Java, JavaScript, C++, Node.js, and Python. In addition, we have an extensive integration with the open source community and Hadoop. Our integrations include NiFi, Kafka, Apache Spark, and Apache Storm. We also have other integration with other messaging tools, ETL tools, and streaming tools. In addition to this, we offer an JDBC ODBC connector to interact with your database of your choice. We also have visualization connectors to Tableau and MicroStrategy. Because of our background, we also provide extensive geospatial capabilities, including connectors to WMS and WKT. Okay, let's go to the demo. So for the demo, what I have here is a Kinetica cluster which maps 4 billion Twitter feeds across the globe. So as you can see, I've clicked the live update button, which shows live tweets coming as we speak. So the record count for the tweets is increasing, and we have more than 4 billion tweets. What I'm going to show you next is the cluster that backs up this demo. So the cluster itself consists of 8 supermicro boxes, each of which has 8 cores and 256 GB of RAM. Each of these boxes have two K80s, which are the GPU, which two K80s GPU, which help with the processing analytics. The total memory usage is close to a terabyte. What I'm going to do now is to go to the Data tab and go to and select a specific table. So the table under question is the Twitter table that I just showed you. As you can see, the Twitter table has over 4 billion records. Now, the table structure itself is like any other database table, right? So you obviously have your columns, your different types of columns and properties. So the type could be a float, string, integer, long, etc. And the properties themselves could be something like a primary key, foreign key, data type, timestamp, etc. One thing which I would like to point out is we have a concept called store only, right? The store only allows you to store your data on your SSDs and have an index in memory. So in case you have a large XML blob that you don't need to search on, but you just need to be stored on your SSDs or your flash drives, marking it as store only will save you that much space in memory. Okay, but at the end of the day, the table itself is like any other database table. Okay, what I'm also going to do is go to what we have as an advanced query tab. Right now, the advanced query tab allows you to search for, execute certain queries. What I'm going to do is to execute an aggregate statistics query. Now, an aggregate statistics query on the Twitter table, which has over 4 billion records, would do a complete table scan on this table. Right. So for doing that, I'm going to choose the sentiment column, which is a number between 1 and -1, which talks about the sentiment of the tweet. And in terms of what I need to aggregate on, I'm going to our documentation page, kinetica.com/docs, and I am going to go to concepts. I'm going to go to the functions page and go to aggregate statistics. Okay, so these are all the aggregate statistics that we support. Right, so let's do some count. Let's do some min. Let's do some max. Let's do a variance. And let's do a skew. And finally, let's throw in some kurtosis. Okay, so when I hit the send button, I'm going to do a table scan of a table which has 4 billion records, and I'm going to do an aggregate statistics of these various things that I want, the various options that I want. Okay, I've completed the query, and it's returned to me in 434 milliseconds. Now, just to show you that this is not cached, I'm going to execute the query once again. Now I get the data even faster in 377 milliseconds, and as you can see, the count it varies, right? So obviously this is not cached. The query executes every single time I do it, and the query runs on GPUs itself. So I was able to get a response time of 377 milliseconds for a table scan for a table with more than 4 billion rows. Okay, and then finally, as part of the demo, what I would also like to do is to show you some geospatial capabilities. Now, if I can focus on the northeastern United States, what I would like to do is to draw a filter, draw an ellipse of a certain portion of the northeast United States. Well, that covered a little bit of central as well, but what I was able to do is to quickly filter down from 4 billion records to 132 million records in a matter of a few milliseconds. Next, I'm going to show you the power of a full text search. So I'm going to search for rain and tire within 5 words of each other in this subset of 132 billion records, and I was able to find 27 records. So again, we did a search and we reduced the filter from 132 and odd million to 27 records. Now if I choose this, you can see that I have the words tire and rain within 5 words of each other, right? So I can actually see the physical tweet. Okay, so that's the demo. So that's all I have for today. Thank you for listening. Again, I'm Karthik Lalithraj, and if you have any questions, you can email me at klalithraj@kinetica.com. Thank you, and have a nice day.